Hello guys, welcome back to my channel, Mason African Motives. So still working on the paper one revision. So this is actually paper one that we are having in this platform. Let's just see, this is, the paper is actually faint, but I'm just going to illustrate some of the parts that are not clear. But I think that's what we have. So we shall just quickly rush through the questions and see what we are given. So if you are to cross-check here, that is a 2-hour, 30 minutes paper. Make sure that you read your instructions, all of them. Which is the most important part here, the issue of working, that you must have everything, because omission of essential working will result in the loss of marks. And the decimals, which are not exact, should be given correct to 3 significant figures. That is, if your answer is not exact, please make sure that you follow these unless stated otherwise. All right, then also the mathematical tables, slide rules, calculators, they are not allowed in this paper. All right, so that was it, guys, from this part. And we are given the first part of the question, which is question number 1, to express the given number in standard form. So as we know, guys, that to express a number in standard form, we must have our number in between 1 and 10. So that's what you're going to have in this case. What can we do to make this number to be between 1 and 10? We just have to move the commas here. That is 1, 2, 3, 4, 5, until this part at 5,26. So it's going to be 5,26 multiplied by 10 to the power of minus 5. Remember, we moved 5 commas, 1, 2, 3, 4, 5. So it's going to be to the power of minus 5. So that's what you had in this case. And let's see the B part. We are given to estimate by first rounding off. So the first thing is to round off first. That is what you're given. Each number correct, that is to one significant figure. So this was significant figure, the value of, okay, so what are you going to have? 3 here, we've given 3,04 and so forth. So this one is just going to be 3. As you can see, this 0 cannot change this 3. So it's going to remain as 3 times 1,98. If we are to cross-check 9, the number that follows is 9. So 9 is going to affect this one and it's going to change into 2. It's going to be 2,00 and so forth. So we just write 2 there. All right, 9,48, this 4 is less than 5. So it can't change this number 9. So it's just going to remain as 9. Everything over 2,9, which is 2 here, 9 is going to change the 9, the 3, this number into 3. Like that. All right, so make sure also to observe your BODMAS and so forth everywhere, guys. Whenever you're dealing with calculations, make sure that the BODMAS part is involved. In this case here, we are multiplying these 2 here, the 3 and the 2, which means we have to multiply first these, which are going to obtain 6. So this is going to give us 6 minus 9, everything over 3. All right. So 6 minus 9, which is negative 3 over 3, and this will give us a negative 1. All right, so that was actually an approximation that you are given. Approximate this one SF depending with what you are given. Then after that, you can simplify using any calculations that you are good at. All right, so that was it. Then express 5,3 square kilometers in hectares. Okay, so remember, guys, I talked about these conversions before. If you still remember, we talked about this where we said a hectare. In a hectare, we've got 10,000 square meters. So this is 10,000 square meters. And what about the part of the kilometers here? We actually understand or know that a square kilometer gives us this is 1 million square meters. So we're going to have 1 million square meters. Where is this one coming from? We know that a kilometer actually is equivalent to 1,000 meters. So when it is a square kilometer, which means you square this and you square. So 100 squared, 1,000 squared is going to give us a 1 million there. So what about 5,3? So now you ask yourself, in this case, what about 5,3 square kilometers? What is it going to give us in square meters? So as you can see, it's a matter of multiplying 5,3 times 1 million. Okay, so if we multiply 5,3 times 1 million, we are going to obtain 5,300,000. Like let's just move on the commas. Here is 5,3. Remember, you're multiplying by 1 million, where you've got to move 6 commas to the right. That's 1, 2, 3, 4, 5, 6. All right, so that's it. In place of these groups here, just put zeros here. So there's a 0 here, there's a 0 here, there's a 0 here, there's a 0 there. So which means you're going to obtain 5,300,000 square meters. Remember, you're converting to square meters. Why are we converting to square meters? Because we have a simpler conversion here that we have got of 1 hectare, which is equal to 10,000 square meters. So now we ask ourselves to say, what about 5,300,000? What is it going to give us as an equivalent in hectares? Because already we need our answer in hectares. So as you can see, it's a matter of dividing by 1,000. That is everything that we are given divided by 10,000. This will be 10,000 now. Okay, so if we divide by 10,000, what are we going to have at the end? That is the question now. Okay, so the zeros there, 3 cancel here, 3 cancel, 1 and 1 cancel. So we're going to remain with 530. All right, so this is going to give us 530 hectares. That is it. The second part B, which is 20 liters in cubic centimeters. So this is cubic centimeters, where we know that the conversion that we know actually, which is direct, is 1 mil, which is equivalent to 1 cubic centimeter. So the best thing is to convert 20 liters to mils, because we also know that in a liter, 1 liter is equivalent to 1,000 mils. So that means 20 liters to milliliters, we are going to multiply by what? By 1,000, and this is going to be 20,000 if we do that. So we are simply saying 20 liters is equal to 20,000 mils. All right, so using this conversion, as you can see, this conversion simply means 1:1. When this is 1, this is also 1. 1 liter, 1 mil, 1 cubic centimeter. So if we have got 20,000 mils, it means we also have 20,000 cubic centimeters, because it's 1:1 type of a ratio that we are given, or type of a proportion that we are given in this case. All right, so this will be 20,000 cubic centimeters. So that's what we had in this case here. All right, 408 hours in weeks and days. Take note, this is in weeks and days. So what are you going to have at the end? We can play around this conversion. Okay, I'm just going to remove everything here. All right, so we are going to play around the conversion that we are given. Remember the issue of weeks and also the days. Okay, so let's start with the days first. We are given 408 hours. Okay, so this is the conversion that we are going to start with. In a day, we know that we have got 24 hours. So this is 24 hours. And in a week, we have got 7 days. So that's what we have here. All right, so the question is, how many days are we going to have? Let's start with the number of days that you're going to have from this 408 hours that we have got. So we can actually ask ourselves to say, how many hours do we actually have in a week? This is a week here, a complete week. It has got 7 days. In a day, we've got 24 hours. So which means in a week, we are going to have 24 times 7. So it's going to be 24 times 7 in this case. All right, which is going to give us something like 168. I'm not mistaken there. So we're going to obtain 168 hours. All right, so a week has got 168 hours. So let's calculate how many weeks do we have from this, subtracting 168 hours, which indicates a week. So how many are we going to have? All right, so you're going to see that here, if we are to divide, we are going to obtain 2, because 168 times 2 is 168 times 2 actually gives us 336 hours. So this is 336 hours out of 408 hours. So it means we are going to have 2 weeks there. From this, we are going to have 2 weeks. All right. And how many hours are going to remain? Because we have 336 hours so far. So from 408 hours minus 336 hours, we are going to remain with 24. This is going to give us a 24 here, which means we are going to remain with 24 hours. And we know that 24 hours indicates 1 day here. We said 24 hours is equivalent to 1 day. So that means actually this is not 24, but this is going to be 72. 72 if we subtract properly, guys. I want you to subtract properly there. 72. I hope someone saw this one. All right, so let's do our subtraction properly. This is 72 hours that we are going to remain with. And out of 72 hours, how many days are there? So just divide 72, divide by 24 hours for a day. So 24 into 72, that is 3. So which means we've got 3 days which are remaining here. All right. So this is going to be 3 days. All right, just like that. So it's going to give us 2 weeks, 3 days. Number 3, we are now given find the value of y such that 6703 in base of y minus 725 base y is equal to 5756 base y. Okay, so how do you attempt such type of equation? It is very, very important for you to understand the concept of bases when you are given number bases. All right. We know that when we are subtracting, we're supposed to have something of this nature. Here, let me just indicate it. We're supposed to have 6703 base y like this, minus 725 in base of y like this, and we obtained 5756 base y like this. This is what actually happened. All right. On a normal circumstance, we know that when we are dealing with the bases, we are supposed to subtract. This is what was going to happen. We are supposed to subtract 3 minus 5. And as you can see, it's impossible for us to subtract. So what happened? We know that we ended up adding the base, which is our base in this case is y. So we ended up adding the base to this 3. So it was like this, 3 plus y. We ended up adding the base. Then when we subtracted the resultant, we had to give a 1 here so that it becomes a 3. So take note what happened when you add the base. Let's just take an example that it was base 9 or whatever base of your choice. We are going to add that, then you subtract now. So from these two, we are going to formulate an equation to say this part that we added here of 3 plus y, this is what we are now having here, minus this number, which is 5, we must obtain this number that we are given, which in this case is 6. So this is what we are supposed to have. So the question is, what are we going to do now to find the value of y? We can actually transpose -1 to this side, -6, 5 to the right-hand side is going to be a plus. So we're going to be left with 3 plus y is equal to 11. All right, then transpose 3 to that side is going to be a minus. So y is going to be 11 minus 3, of which 11 minus 3 is going to give us 8. So that is the value of y, which is the best. If we are to cross-check further, we can prove this again. Remember, that was this stage. We can even go to this stage here where there is a 0 here. Remember, 0 minus 3, it's impossible. So we added the base, which is y here, and 0 plus y, that's y here. So it's going to be y, and we give a 1 here, and this becomes 8. All right. Then we have to subtract. Remember, that is what you do when it is impossible for you to subtract. Then we have to move on and say y minus this number now, which is 3. Y minus 3 is equal to the answer that we have got here, which is 5. So which means y is going to be minus 3 plus 5, which is 8. So as you can see, guys, we are obtaining the same value of y throughout. So using the first part alone is enough. Yes, we can do this to just prove on and see exactly what you're going to have, but that was our value of y. Okay, so in this case, y is equal to 8. All right, so let's see the other question. I'm just going to erase this part here. All right, so I'm just going to remove this part, guys. All right, so the other part that we are given is convert the given number 143 base 5 to a number in base 2. Okay, so in base 2, remember, we can convert to base 10, then divide by the base throughout. So this is 5 to the power of 0 here, 5 to the power of 1, 5 to the power of 2. Okay, so that means we are supposed to multiply 1 times 5 to the power of 2 plus here it's 3 times 5 to the power of 1 plus here it's 4 times 5 to the power of 0, like this. All right, so this is what we actually had. 5 to the power 2, which is 25, 25 times 1, which is 25, plus 5 to the power 1, that is 5 times 3, which is actually 15. 5 to the power of 0, that is 1. 1 times 4, which is 4. All right. Then we add 25 plus 15, that's 30, plus 10, which is 40, and 40 plus 4, which is 44. Okay, so this is 44, which is in base of 10. And to convert in base of 2 now, you just have to divide by the base throughout, which is 44, noting the remainders down. So these are the remainders here, dividing by 2. All right, so let's do the division, guys. 2 into 44, that is actually 22, remainder 0. 2 into 22, that is 11, remainder 0. 2 into 11, that is actually 5, remainder 1. 2 into 5, that is 2, remainder 1. 2 into 2, that is 1, remainder 0. 2 into 1 here, that's 0, remainder 1. All right. So this is what we had, and we know that our answer is supposed to be taken from the bottom here going upwards. So we've got 1, 0. We just take those numbers from the bottom. So we've got 1, we've got 0 here. We've got 1 and 1, which is 1, 1. All right. We've got 2 zeros here. That's 0 and 0 here. So that's 0, 0 in base of what? In base of 2. All right, so that was it, guys, for this question. It was just direct, as you can see. Okay, so the first answer was what? Was 8. Okay, why was 8 there? So these are the typical questions, guys, as you can see. That's how they ask these questions. On number 4, you're given that there's a shop that one loaf of bread was costing 65,000. Find the cost of dozen of loaves. So you know that dozen means what? Dozen means 12. So a loaf costs 65,000. What about dozen? Dozen 12. Just multiply. All right, so that is the cost. So it's $65,000 multiplied by 12. All right, so if you multiply by 12, we are going to obtain 780,000 if we multiply properly there. All right, so that was just multiplication, guys, as you can see. On item 2, the number of loaves of bread that could be bought for 4,450,000. How many are you going to buy? So the number of bread means out of these, if one cost is 65,000, what about one? So you just divide, okay? So it's 4,550,000 divide by 65,000. All right, so you divide by 65,000. So how many are we going to have at the end? Yeah, we can just divide the zeros here, 3 zeros here. You can choose to reduce by 5 if possible. 5 here, that's 1 into 15, which is 3. 5 into 45, that is 9. 5 here, that is 1, 0 here. 13 into 13, that is 1. 13 into 91, which is 7 into 0, that is a 0 there. So you're going to obtain 70 loaves. Okay, so the number of loaves which can be bought for this amount was 70. Okay. Write down the type of variation which connects the cost of bread and the number of loaves of bread, the cost of bread and the number of bread. So this one is actually a direct, like the type of variation. Okay, so this one is just direct variation. Why? As the bread, as we increase, like it's increasing, as you can see. Okay, so whereas one is increasing, the other one increases. If you decrease the number of loaves, you decrease your amount that you're going to have. If you increase the number of loaves, you're going to increase the amount that you're going to have. So it's a direct variation. It goes in a direct way. All right, so this is direct variation. Let's see, number 5, we are given, right? One capital letter of the alphabet, which has rotational symmetry of order 2, but no line of symmetry. So there is a line, there's a letter that we have. It doesn't have the line of symmetry, but it has got order of rotational symmetry. Which letter is that one? Okay, let's see, capital letter Z. What does it look like? Like this. Yes, you can rotate this and it becomes Z, but we have line of symmetry. No, it doesn't. If you cover this, it can't be covered. So we've got letter Z there. All right, so when we've got letter Z, we also have letter N. Letter N and letter Z, they end work hand in hand. But if we rotate, is it going to give us the exact thing? So try and rotate letter N and see if it is going to come out with the same thing. Yeah, maybe it can give us the same thing there. All right. Then B, we are given the mean of M, P, Q, Q and R is 8,25. The mean of M, N, whatever that you have is 4,6. So what is important here, don't be confused by these letters. What is important is how many letters we have. We've got 1, 2, 3, 4. So this is the mean of 4 numbers, which is 8,5. And here, this is 1, 2, 3, 4, 5. The mean of 5 numbers is 4. That is what it simply means. Okay, so what is the value of N? The value of N is the number that we, as you can see, N is the only term here. M was same, P was there, Q was there, R was there. So N is the part that we added to these terms so that they become 5. There were 4 previously, now they are 5. So what are you going to do? Find sum of 4 terms. Remember, guys, I told you that mean is equal to the sum of terms over the number of terms. That is your mean. So your mean, in this case, is going to be sum of terms over number of terms. All right. So the sum of terms, in this case, is the one that you are referring to. I don't know which letter you're going to use, but we are given for the first 4 numbers, these ones, for the first 4 numbers, the mean is 8,25. So you're going to say 8,25 is equal to the sum of the 4 numbers. So here we are referring to 4 terms. All right. So we do not know the sum, which is the total here. We do not know the sum, but we know that these terms, they were 4. All right. So how can we find X? We can just cross multiply here, 4 times 8,5, 1 times X. So 1 times X is X. 8,25 times 4. If you multiply this, you're going to obtain 33 if you multiply properly. Okay, so this is the total of 4 numbers. Okay, we move on. We do the same here. Mean of 5 terms now. 1, 2, 3, 4, 5 terms. They've got a mean of 4,6. So mean is 4,6. The sum, we do not know this sum. So you're just going to write it as Y. This one, do not use same letters, just use another letter. You can use any letter of your choice. Okay, so this is sum of what? Of 5 terms over the total number of terms, which is 5. Okay, so you can find the value of Y again by cross multiplying 1 times Y. That's Y is equal to, so it's going to be 5 times 4,6. Okay, so Y is going to be, if you multiply properly, we are going to obtain, let's see. Oh, we can just multiply 5. That's 30. We've got 3 here. 5 times 4, which is 20. 20 plus 3, which is 23. 1 decimal place, so it's 23 there. So the sum of 5 terms is 23, which is lesser than the sum of 20 of those 4. That one is not important about that. So here we are given the sum of 5 terms. Okay, so what is the value of N? N is the 5th term that we added to these 4 terms that we had. Remember, these are 4 terms and these are 5 terms. So it means our N in this case is going to be 5 terms, the sum of 5 terms, because here we are referring to 5 terms. Okay, so it's going to be the sum of 5 terms, which is 23, minus the sum of 4 terms, which is 33. So if we subtract this, we are going to obtain -10. It's not about bigger number minus smaller number. No, sum of many terms minus the sum of that one with what? With the fewer terms, so that you're going to obtain the term that you added to these 4 terms so that they become what? They become 5. Okay, so that was it there. Number 6, we are given the radius of a circle is 9 centimeters, correct to the nearest whole number. So which means in this case, that is not the exact value, but it's a rounded figure. Okay, so that is why now they're asking us to write down the limits where of which area is going to lie. Okay, so let's see, we are not given how to write this one. So our area is going to range from the least value here is 1 less than this. Remember, it's to the nearest whole number. Okay, so the smaller value is going to be 8,5 up to 9,4. Remember, that's how we write it. So in this case, now you can write it as r is greater than or equal to, we say the smaller value is 8,5. So 8,5 can be part of our answer, 8,5, but less than, if you want to use the less than, then you are going to write this as 9,5. If you use less than. If you use less than or equal to, you are going to write it as 9,4. So take note, it's about the inequality sign that you are going to use. So if I use less than or equal to, I'm going to use 9,4. If I use less than here, all right, sorry, I'm now writing the other way. So if I use here less than, I'm going to use 9,5. All right, so that is the case about this type of a question. All right, so that is it for this part. Let's see the other part that we are given. Calculate the least possible circumference of the circle, giving your answer in terms of pi. Okay, so take note, guys, your answer is needed in terms of pi. And we need what? The least, which means we are going to use this smaller value, which is 8,5. That is the least. Okay, this is the circumference. We know that the circumference of a circle is given by 2 pi r. That is the circumference given the radius, but it's needed in terms of pi, so it's going to be 2 pi times the radius, which is the smaller radius, which is 8,5. Remember, this is your radius, so you're going to multiply by 8,5. Okay, so 2 times 5, that is 10. 2 times, which is 16, plus 1, which is 17. How many decimal places we've got 1? So it's going to be 17,0 pi. So which is 17 pi. 17,0 is 7. Is same as what? Is same as 17. Just like that. So I think this one is direct. Then the other question, which is question number 9. This is 7. This is question number 7, actually. We are given from A to B, the distance in between here is 98, and it's made up of, these are semicircles. So from this point to this point is a semicircle. From that point to another point, it's another semicircle. From that point, and so on and so on. As you can see, guys, it was actually made of what? Of semicircles throughout this part. So maybe it can actually be clear if I do it this way. So these are just the semicircles that were made from this particular section. So how many semicircles we put? 1, 2, 3, 4, 5, 6, 7. So there are 7 semicircles there. So the question is to calculate the diameter of each semicircle. That is the first part, to calculate the diameter of each semicircle. And as we can note here, given 78 from this point, 98, yeah, 98 from this point to this point. Okay. So, and from this point to this point, that's your diameter. That's the diameter. So how many diameters are there? These are 7 diameters which are there. So it's simply dividing 98 divided by 7 semicircles. And that's 7, which is 1, remainder 2, which is into 28, which is 14 centimeters. Okay. So each circle, each semicircular that we have here, it has got a diameter of 14 centimeters. So this is like 14 here, 14 here, 14, 14, 14, each and every part. All right, so that was it, guys. As you can see, it was actually pretty clear. So you just have to understand what is the presentation meaning. What does this presentation actually mean? And the other part now on B is to calculate the distance from A to B along the curves. So we are talking of this distance along the curve. Here, this is your curve, guys, the one that we are referring to. This is the curve from this point to this point. That's the first curve. And then we have got this curve here from this point here to this point. It's another curve. So as you can see, we have got 7 curves. So what we just need is to calculate the length from this point to this point along the curve of 1, then whatever that you're going to get, we multiply it to 7. Okay, so the length of the curve is the length of the arc. And how do you calculate the length of the arc? Remember from your formulas, guys, length of arc is equivalent to theta over 360 times 2 pi r. But in this case, it's a semicircle. So instead of using theta over 360, it's going to be half 2 pi r. So it's going to be half times 2 pi r. It was supposed to be theta over 360 times 2 pi r. But our theta in this case is 180 degrees because we've given a straight line, which is a diameter. So it's just going to be half there. So this and this can cancel, which means you're going to be left with pi r, okay, which is pi 22 over 7. So it's going to be 22 over 7. Always use the given pi. The given pi in this case is 22 over 7 times the radius. Take note, here we have got the diameter from this point to this point. So the radius is going to be 7 here, 7 here. So the radius is 7, diameter divided by 2. So our radius is 7. All right, so that's it. Multiply, we are going to obtain 22 centimeters. So this is the length of arc of one semicircle, okay? And we've got 7 of them from A to B, from this point of A to B, from this A to B. There are 7 of these. So we're going to multiply by 7. So therefore, we are going to have a total of 27 times 22 times 7, which is 154. Yeah, this is going to give us 154 centimeters. This is length. Length is measured in centimeters, just like that. All right, so that's it, guys. As you can see, it was pretty clear, and you just have to work on along the lines and so forth, yeah, so that we can actually understand what is happening here. Then the Venn diagram number 9, number 8 is actually number 8. We are given the Venn diagram, whatever that we have got there. The first part is to, from the Venn diagram, list the elements of P intersection Q. All right, so where is P, where is Q? If you had to cross-check, this is your P, this is your Q, and Q here is a subset. This Q is a subset of what? Of P. Okay, so meaning to say, what is in Q? These elements in Q, that's your intersection whenever you're dealing with a subset. So A, B, and C, that's your intersection whenever you're given what? A subset like that. So we said we've got A, B, and C. All right, so that's it for this particular question. I think it was also direct, this one. Okay, let's see the other part of the question that we are given. All right, let's just remove this part here. All right, let's see. We are given P complement, yes, P complement, intersection Q complement. Okay, there is this law, guys, that you must know. It's difficult for you like to demonstrate this, but you must know that this is equivalent to P union Q complement. Take note like that. You interchange this intersection to union and the whole bracket will be complement, which means P complement union Q complement like this is equivalent to, you interchange this, it will be P intersection Q complement. So these two, they are the same. So it's difficult for you to work with this, so you use this one. It's difficult for you to work with this, so you use this one because it's easier, guys. As you can see, P union Q complement, it means what is not in P and Q. Then this is your P union Q. The whole of this P and Q, they are inside here. This is where your P and Q are located here. All of the P and Q, they are here. This is where your P and Q are. So what is the complement? The complement, it means outside of this part. So which means outside we've got H, we've got I, we've got K. This is complement, not in that set, but outside. So we said H, I, and K. So this is going to give us H, I, and K. So these are the elements. So it's easier to understand this language. Is going to be very, very easy for you. Okay, B, number of elements in P. So you just have to calculate how many elements are in P. Let's go to our P. All right, this is our P, the one that we shaded here, the one that we put all these things here. So let us just see our P here. So how many elements are there? We just need to calculate these elements in P. So take note, P contains A because contains Q. We said Q is a subset of P. So P contains a Q. P contains Q, which means Q is inside of P. So when you are calculating P, you are calculating also what is in what? In Q. So how many elements? We've got 1, 2, 3, 4, 5, 6, 7. So calculating how many elements, that is the question. So we've got 7 elements there. All right, so that was it. I think it was pretty direct also. You just have to calculate from the diagram that you are given there. All right, so let's move on to the other part of the question, which is number 9. There we are given distance. This is a distance time graph, not a velocity time graph, but this is a distance time graph. So take note, guys. This is distance in kilometers, okay? And the time in hours, not velocity in meters per second. This is distance time graph. Okay, so the question was to calculate the time spent at the shopping center. All right, where is the shopping center? This is our shopping center here. We arrived at the shopping center and departed from the shopping center. So at 3 to 5. So this is the time between these two. So it's 5 minus 3, which is 2. So here we've got 2 hours in between. That was the time that was spent at the shopping center. So this is 2 hours. Okay. The average speed for the whole journey. Okay. So when you are dealing with the distance time graph, this is what you're supposed to do to know this here. This is your total distance. It indicates, or it gives you the total distance, which is 36 kilometers. And this is your total time, which is in this case is 8. All right, so I want us to see in this case, the average speed. We know that our speed in this case is equivalent to distance over time. So that will be our average speed. All right, let's just write this, which is distance over time. If you forget this, remember to use your DST. This diagram here, DST. Okay, so we need speed, so which means I'm just going to cover up this part with speed here, and I'm left with distance over time. Okay, so let's do this. Let's substitute our values. Our distance, we say that is the total here, which is 36. So that's how you actually attempt this type of equation. So over the time, how many hours, which is 8 here, the time is 8 hours. So it's going to be 8. So you just have to reduce this until the last part. Okay, so this is going to give us by 4. Yes, we can just try by 4 here, by 4. That's 2 by 4 here, that's 9. 2 into 9, that is 4. Remainder 1 over 2. So this is our speed in kilometers per hour. Remember that distance was in kilometers, your time was in hours. So it's going to be 4.5 kilometers per hour or 4.5 kilometers per hour. It's just one and the same thing. So that was it, guys. As you can see, that was it. All right. 10, a ball contains 60 identical marbles except for color in a bag of 36. Take note, we've got 36, which are the X are red and the rest are blue. Okay, 36 are green. X are red and the rest are blue. Okay, so we know that the X is for red, the rest are blue, and 36 are for green. Okay, if the probability of selecting a red marble at random is 1/3, find X. Okay, so take note, guys, we have got red here. If we knew this, we are going to say, actually, we know that the probability of picking red is the number of red marbles which are there, which we do not know in this case, over the total, which is this case, our total is 60. All right, so the probability of this one is the one that was reduced and we got 1/3. So this is what we just had, guys, before. Okay, the number of red over 60 gave us 1/3. So what is this number of red? We do not know. So we're just going to put it as X, or the one that we are given, because we are told here that X represent what? Red. So in place of red, you are going to put X. So what is the X? Cross multiply, or you can just multiply by 60 here. All right, just multiply by 60. To remove this 60 here, also multiply by 60 here. So this can cancel. So X is going to be 3 into 60, which is 20. So 20 will be the number of what? Of the red marble here. So which means this X that we're talking about is 20. All right. So how many blue are there? Now we have to go back here where we said the rest are blue. So which means 36 plus 20, which is 56. 56 from 60, which is 4. So which means 4 are blue. All right, but in this case, we wanted the red marble. So the answer was just, yeah, I'm just saying for this one, because we just need to know how many were there. And B, 2 marbles are chosen or drawn one after the other with, take note guys, answer the question here with a replacement. So which means you are returning whatever that you take, you have to return it back. Find the probability that neither marble is green, giving your answer as a common fraction in its simplest form. When they say neither, it means not green. We want the part that is not green, not green, but any other color. Guys, this is what you have to understand, because this one, I think you are used to it here. Just cross-check this part. Neither, you must understand, when they say neither mathematical two, they are here they are not allowed. This is not part of the paper. They are not even included either here. So which means we do not use these ones, but they are, we see what is exactly this part. That, so guys, you must understand this basic language. All right, so it means that one is not actually needed for that moment. All right, so the green is not needed here. We are talking of any other color, but not green. Okay, so it was best for us to just have a probability tree diagram, since we chose 2 in this case. All right, guys, and it was going to give us a lot. This was going to give us a lot, guys. Okay, let's just see anyways what you're going to have. But since okay, we can do it in a shorter way. I just want to shorten this. Since here we said we are going to neglect what? The green part, because we are saying this green is not involved. So it means we are going to neglect the green. We are supposed to have 3 branches like this. Okay, that is where we are going to have it. We were supposed to have actually 3 branches. This is what was supposed to happen. I want you to understand, guys. I want you to understand this basic part. You were supposed to have green here, and you have red and blue. This is what you're supposed. But they are saying green is not included. Okay, so let's fill in this way. Remember, it's with replacement, which means whatever that you're going to take, you replace it back. Okay, so the green, how many green are there? Green is actually 36. So it's 36 out of this total, which is 60. Okay, so it's 36 out of 60. 36 out of 60 here. Red in this case, red was red, we obtained 20. Remember, we obtained our red that time. It was 20 out of 60. Blue, we said we are going to remain with the 4, which are blue here. All right, so blue was 4. So this is what we're supposed to have. Then you do another diagram. But yes, since this green is not involved, this is what you're going to do. You are just going to focus with where there is what? Red and blue. So which means this is what you're going to have here. So which means we are going to focus with only 2 branches here, that is got red and blue. But the red and the blue part, they are going to remain as they were before. The red here, because you pick a marble, then you replace it back. So you haven't done anything. You haven't affected anything. So the red was going to remain as it is, which is 20 over 60. The blue was going to remain as it is, which is 4 over 60. The same thing here, the red was going to remain as it is, 20 over 60. The blue as it is, 4 over 60. But knowing that there is that green, but we are not focusing now with that green, because they are saying the green is not included, neither green is not there. Okay, so which means definitely your outcomes were going to be red, blue, blue, red, and blue, where there is no green. So there was no need for you to complete the whole diagram, just a piece of that diagram. So you need to know your diagram so that you can also know how to minimize that diagram in exam condition. Okay, so these are the outcomes that you're going to have, which does not include green. All right, so you're going to combine the probability of, we say the probability of red. So this one is going to be red, plus the probability of red, blue here, red, blue. So this is red, blue, red, blue, then blue, red, plus the probability of blue, red, plus the probability of blue, blue, just like that. Okay, so red means we are going to multiply this part of red to red. So since it does not change, it's going to be 20 over 60 times 20 over 6, just like that, because this does not change. 20 over 60 times 20 over 60. Okay, plus we move on to red, blue. This is red, blue, red, followed by blue. So it's 20 over 60 times 4 over 60. So this is 20 over 60 times 4 over 60. Okay, so that's it. Plus blue, red here, which is blue, red, 4 over 60 times 20 over 60. So it's 4 over 60 times 20 over 6. So under exempt conditions, some of these workings are not supposed even to indicate them if you actually know this diagram. Okay, 4 over 60 and 4 over 64, blue. So it's going to be 4 over 60 times 4 over 60. All right, so that's it, guys. What you're going to do is to reduce the numbers. After you're done, guys, you have to combine. Okay, so that's it. The first part was going to give us 1 over 9 plus 1 over 45 here, plus 1 over 45 again here, plus 1 over 225. All right, so if we add everything, it is going to give us 4 over 25. So I want you guys to add everything there. You're going to obtain 4 over 25. You add, find the LCM and so forth, or you can just simplify in a better way that you can understand. All right, but like I said, guys, you are not supposed to do everything as it is, and this question does not make sense. 3 marks, 2 marks for just this. Okay, anyways, you just have to try and see what we got then. All right, but that was the part again, guys, that we got here. In the diagram, A, B, C, D is a circle, center O. So we are given a circle, center O. So definitely when there's a circle, it means A or B is a diameter. And we know that a diameter subtends an angle of 90 degrees at the circumference of the circle. And from O to C, from O to B, from O to A, these are radii. They are the same. They're equal. Okay, so that's it. Okay, let's see. Let's rush to the questions. Calculate BCD. Okay, this is our BCD. Okay, that's BCD. This angle here from B to C to D. That's the angle here. All right, so what are you going to see? What are you going to use here? As you can see, we are given the whole of angle A, and these are opposite angles of a cyclic quad. A, B, C, D is a cyclic quad. All the 4 vertices are on the circumference of a circle, so that's a cyclic quad. So what are you going to do? We just have to subtract from 180 because we know that opposite angles of a cyclic quad, they add up to 180 degrees. So this one is just going to give us 180 minus 55. And 180 minus 55 will give us something like 125 degrees. Okay, then that's it. Let's move on to another part, which is B, ACB. Okay, ACB, we already indicated that this is 90 here. As you can see, guys, we already indicated that it's 90 from the right angle subtended by a diameter. We said it gives us 90 degrees. Okay, then we move on to DAC. That's DAC here, from D to A to C, which means we are referring to this angle here. All right, so take note, guys, from these 2 chords, from this arcs DC, this arc DC here, they are saying this arc DC and the arc DA, these ones, they are equal. So it means also these chords, they are equal. So if these chords are equal, it means these 2 angles are equal. This angle at A and this angle at C, they are equal. All right, so we are going to take advantage of this angle at C, DCA. Why? Because remember previously we got the whole of this angle, we got it before. We said it's 125, okay. And this angle, we said it's 90 degrees. So it is going to be 125 degrees minus 90 degrees to find the remaining angle, which is something like 35 degrees. So if this angle is 35 degrees, it also means this angle is 35 degrees. These are angles which are opposite what? Equal sides. So if you're given angles that are equal, opposite sides, they are also equal because we are going to have what? An isosceles triangle. So this is 35 and also that one is 35 degrees. Okay, so that's our DAC. It's going to be 35 degrees. All right, just like that. I think it was pretty clear also. Given to simplify, this is -32. Let me rewrite it down. -32 to the exponent of 3/5. This is 3/5, like this. All right. So what do we know, guys? Remember from your laws, if you're given a fractional exponent like this, it's going to be the 5th root of -32, everything to the exponent of 3. So what is the 5th root of -32? A number that is going to multiply itself 5 times to give us a -32, and that is -2 to the exponent of 3, and -2 to the exponent of 3 is -8. Where are we getting this from? -2 times -2 times -2. Negative times negative, that's +4, times -2, which is -8. So it's going to be a negative there. All right. So that's our A. Okay, B, we are given 1/5 to the exponent of -3. Okay, so how do we remove the exponent of a negative? This one, 5 to the exponent of -3 is 1/5 to the exponent of 3. So this is going to give us 1/5 to the exponent of 3, which is 125. So actually dividing, or 1/, this simply means the inverse, which is 125/1, and this will be 125. So the answer is going to be 125, or it simply means you are dividing like this, 1 divide by 1/125. That is what it means. This one here divide by this, and you have to multiply by 125/1. Remember, when you introduce multiplication, you invert the second fraction. So that is going to be 125, just like that. Factorize number 13 completely. So you have to check, do you have anything common between the 4 terms, between the two? Yeah, we work with 2 terms separately. If we divide the 2 terms separately, do you have anything common on the first part? Like, do you have anything common? Yes, we have got something common here, because we can actually do this into 2. 3 is common here, if I'm not mistaken. So you can factor out 3. And that's 3 into 15, which is 5. So it's going to be 5m plus 6. So you've got 5m plus 6 there. And on this part, n is common. First, negative and negative is common. And between 5 and between 12 and 10, 2 is common. Then n is common. So this is our common term. So let's factor out -10mn divided by -2mn. Minus and minus cancel. 2 into 10, that is 5 here. So as you can see, n and this n will cancel. So there's nothing there. Also, here, negative and negative, that's a positive. So it's going to be positive. We said we've got m. We are left with m because n cancelled. So we are left with n. Okay, then here, -12mn. So the n and the n will cancel. And 2 into 6, which 2 into 12, which is 6. It's going to be a 6 there, because it's negative and negative, which is going to give us a positive. The 2 brackets are the same. So factor out that common bracket, which is the same. All right. So if I factor out this bracket, I'm going to be left with 3 minus 2n. So this will be 3 minus 2n. All right. That's it. We are done on this part. Okay. On this B, 27x squared minus 12 y squared. Okay. 3 is common. Yeah. 3 is common. First, 3 into 27, that is 9x squared. Minus 12 divided by 3, which is 4y squared. So as you can see, guys, we are going to end up with difference of 2 squares, which needs the 2 brackets, square root of 9, which is 3, square root of x squared, that is x. 1 bracket adds, remember that, square root of 4, that is 2, square root of y squared, which is y here. So it's going to be 3x minus 2y. Okay, so that's it. One of the bracket will add, and another one will subtract. I think I talked about all these things, guys, and it's clear, very, very clear. Okay, number 14. The following is an extract of Mr. Duve's telephone bill for the month of January 2002, whereby X is the number of units and Y is the value added tax, VAT. That's what you're given. So X, where is our X here? The units which were used. All right, so you have to study the diagram that you're given, study the table there. Okay, find X, which is the number of units used. Okay, how many units were used? So we have to cross-check with the units here. Metered units is 0.2. So take note, guys, these are the metered units that we got here. These are the metered units which are indicating. And our previous units was this one. This is your previous unit. So how do you find X? You just suppose X, these are the units which were used. So you subtract the difference between. So our X is going to be 0.2781. The metered units minus the one that we are given there, which is 0.685. Okay, so if we subtract these units, we are going to obtain 1096. So make sure that you subtract properly, guys. We're going to obtain 1096 units. So X represents the number of units which were used. All right, B, the cost per unit. What is the cost per unit? Okay, here we are given that these units, all of them, they are to cost $2,192. This is the cost of all these units. What about each unit? So it's a simple proportion. We are going to divide this amount for the number of units divided by the number of units, and the cost for all the units is what, $2,196. All right, divide by how many units were used? We used 1096 units. Okay, so guys, I want you to divide here, and you're going to obtain a 2 there if you actually do it properly here. You're going to obtain 2, if I'm not mistaken. Yes, 2,00. So remember, this is amount money, so it's going to be 00 there, $2. So it's $2 per unit. Yeah, if you multiply by 2, do you get that value if you multiply by 2, guys? Or it's actually we have to redo and redo, but try and see if we are going to obtain the same thing. I'm just gonna cross-check along the lines. You see this issue of working aside and doing these things aside, but that's what we actually had in this case. It was 2,196 divided by, you are not supposed to use calculators actually, you guys are not supposed to use calculators. Yeah, it gave something like 2,000 something like, but this is money, so you round off to what? To 2 decimal places. That's why we have to end up with this, because it was giving us 2,003, something like that. Okay, so it's going to be $2. Okay, then the VAT here, which is the value added tax, which is Y here. So value added tax is at 15%. So it's 15% of the subtotal. Remember, guys, I told you that it is 15% of this subtotal here. That is where your VAT applies. So it's 15% of this subtotal. Okay, that's 15% here, which is 15 over 100 times the total, which is 2,332. Okay, so this is $2,332. Okay, so you're going to obtain the VAT, which is Y. So guys, can you do these calculations aside? You're going to obtain something like 349,80. This is money, so you just have to round off to 2 decimal places after the comma there. So at the division part, guys, can you just do that one? Can you just do that one? Okay, can you just do the division part and you get, at least the idea is the one that is important. Are you do you know what is happening? That is what is important. Okay. Then we are given a rectangle. It's a triangle, measures 7 centimeters by 5 centimeters, and X is an integer. Find the minimum value of X. Okay, this is what we are supposed to know, guys. This relationship is very, very important. Whenever you are referring to a triangle, okay, let's say A, B, and C, like this. Okay, if A and B, this is what I want you to note. If A and B are the shorter sides. The shorter sides. All right, therefore, A plus B, the shorter sides, must be greater than C. The sum of the shorter sides, whenever you're dealing with a triangle, okay, the shorter sides, when you add them, they will always give you a value that is bigger than the what? That is bigger than the third side, which is the larger one. Because I'm saying if A and B are the shorter sides, which means this is the bigger side. So if you add the shorter sides, they must give you a value which is greater than the bigger side. Okay, so now they are saying what is the minimum value of x, which means x is one of the shorter sides. Okay, and if you are to cross check here, let us analyze our triangle. It has got 7, 15, and x. So if x being minimum, it means it's also the shorter side with this 7 here. So x and 7 are the shorter sides, and 15 is going to be our bigger side. So it means the shorter side of 7 plus the shorter side of x. If we add them, they must be greater than this value, which is 15. They must be greater than 15. Okay, so what then is going to be our x? So you can play around this. X is greater than 15 minus 7. So our x is greater than 15 minus 7, which is 8. So we are saying our x is supposed to be greater than 8. This is what we are supposed to have. But this x is an integer. So which is the smallest integer that we have that is greater than 8? So which means we need the smallest number that is greater than 8. And definitely that number is 9. That is the number that you're going to have. The smallest integer greater than 8, because the integers that we have greater than 8, we've got 9, 10, 11, 12, and so on. So the least or the smallest there is what is 9. So therefore our x is going to be 9. Okay, B, what is going to make this x to be the maximum value, which means for our x to be maximum value, it means 7 and 15 are now the shorter sides. These 7 and 15, these are now the shorter sides, and x is the larger side of the bigger side. And we said shorter sides should be greater than the bigger side. Okay, so now you are saying 7 and 15, these are your shorter sides. So 7 plus 15 should be greater than this side here, which is x, because now we are saying x is your greater side. So we are saying 7 plus 15 must be greater than x. Okay, so this is the item 2 now. All right, so 7 plus 15, which is 22. So 22 is supposed to be greater than x. So what does it mean? If we say 22 is greater than x, it simply means reading from this side of x to this side, from x to this side, it means x is less than 22. X like this is less than 22. That is what it simply means. It's just one and the same thing. So which is the integer, the biggest one, the largest integer that is less than 22? So take note of 22. We've got 21, we've got 20, we've got 19, we've got 18, but which one is the biggest? Therefore, the biggest here is 21. So therefore, our x is going to be 21. So guys, you must know the properties of a triangle. This type of a question needs you to know what is a triangle, what is it made of. It's not about just writing the sides to say this is 3, this is 7, no. The shorter sides of a triangle must be, I want you to cross-check every triangle that you're going to see from now. I want you to cross-check this. If you add the shorter sides, you're going to see that they will be bigger than the bigger side. Okay, so I want you to do it from now onwards so that you understand this part. Maybe it's going to help you as we are moving on. Okay, find the number of the sum of interior angles of an irregular polygon is 5040. Find the number of sides of the polygon. All right, so then remember, guys, I told you that when it is a polygon like this, it is whether it's irregular or it's regular, the sum does not change. Okay, the sum of the interior angles does not change. It still goes back to n minus 2 times 180 degrees. That is the sum, and that sum gave us 5040. So how many sides, which means we have to calculate n. So you can divide by 180 by 180 here. So this can cancel. N minus 2 is equal to, reduce this, you are going to obtain something like 28 if you reduce properly here. So n is going to be, let us transpose, minus 2 to this side of the equation is going to be a plus 2, which is 30. So n is going to be 30. So this polygon has got 30 sides. All right, so that was it. That was it there. 16, the selling price of a school shoe at a departmental store in January 2005 was $750,000 per pair. Okay, that was our Zimbabwean money. Calculate the amount paid for one pair of school shoes if 10% discount was allowed. Okay, this is 10% discount. So whenever that you've got a discount, you just have to calculate the 10% of this amount, which is the discount. So it's 10% of 750,000. Okay, that's a discount, 750,000. Let's just put this 0 here and this 0 here. So we're going to have 7500 times this 10, which is another 0 here. So which means 75,000 was removed as a discount. So you subtract that from 750,000. We have to subtract 75,000. So you have to subtract 75,000 as a discount. 75,000 or 7,500. Guys, how many zeros do we have here? We've got 3 zeros in this case. All right, so it's going to be 75,000, not 7,500, but 75,000 like this. Okay, so that's it. Let's subtract 0, 0, 0, 0 here. 1 here, that's 8. 5, 1 here, that's 1. 15 minus 8, that's 7, and this is 6, so it's going to be $675. Okay, so just subtract properly, guys, and see if you're obtaining the same thing. Okay, but that was it, guys, just like that. Okay, B. In February 2005, now we are given the price rose by 15%. Okay, that is now in February. Okay, so take note, this is in January, like in January is like this. Okay, forget about the discount. We are now back to the normal price. That was just a discount. Now we are back to the normal price, which is at what? At 750,000. The price rose by 15%. Calculate the new selling price of one pair of school shoes when it rose by 15%. So it means this is an increase. All right, so what we are going to do, we have got so many ways. We can find 15% of this value. Then we add, just like what we did, but this time we have to add because it's an increase. Here we have to subtract because it was a decrease. Okay, so you find 15%, then you add. But since we have used this type of method, I'm going to use another method this time. Let's just use this one to say that in January, the price of a shoe was at 750,000. This was the price of the shoe at 700. This is initial price, like at 100%. Okay, so at 100%, the price was at $750,000. It was at $750,000. Okay, then in February, after this, now there's a 15% increase, which means we have to increase to this percentage of 100 plus 15, which is 115%. All right, so now it is going to be at 115% after the increase. That is the amount now. So you're now asking yourself to say, at this 115%, what is the total that you're going to have there? So as you can see, it's just a simple matter of calculation, as this one is going to give us more. So it's going to be 115% over 100% times 750,000. All right, so that's it. The zeros here, they cancel, the zeros here cancel. Then I want you to multiply these two numbers. You are going to obtain something like 862,500 if you do the multiplication properly. I just want you to cross check, guys, if you did, if this is actually correct. Okay, but the idea there is just direct like that. All right. Then number 17, we are given that in the diagram, BC, DCB, this DCB is a straight line, BC 15, and also that we are given the theta, and we are given that sine theta is 3/5. This is your sine theta here, which is equal to 3/5. So there's something like this, whereby we know that sine is actually opposite over the hypotenuse. So 3, this was supposed to be 3, and this was supposed to be 5, opposite over hypotenuse like this. So if this is 10, it means this is 6, because as you can see, this is 5, but on the diagram is what? Is 10. So it means this 3 times 2, because you just multiplied 5 times 2 is 10. So 3 times 2 is going to be 6. So this side is going to be indicated by 6. All right, so that was the triangle. Okay, so the value is for us to calculate cos theta. Okay, that is cos theta, which is this one, cos theta. So as you can see, cos theta it's adjacent, and this is your adjacent here over the hypotenuse. So you need to find this side here, the third side. So how can we find the third side? We can actually use our Pythagoras theorem. Remember to calculate the third side, apply your Pythagoras theorem, 3, 4, 5. We know that 3, 4, 5. So this one is going to be 4 here, okay? But previously, this was 3, 4, 5. Now it's 10, 6, 8. So this one of 4 is going to be 8. Okay, so I want you to use Pythagoras theorem, guys. You're going to obtain 80. I'm not going to work with Pythagoras. I'm just going to indicate. So these are the values that you're going to work with: 10, 6, and 8. Okay, so you know that you guys, you must know these Pythagorean triples. Okay, 3, 4, 5, 6, 8, 10, 5, 12, 13. There are so many actually that you can actually have or work with, so many. So we just need to know all these Pythagorean triples. Okay, so anyways, cos theta, remember that cos theta, cos is adjacent over hypotenuse from your soccer tower. This is adjacent over hypotenuse, and our adjacent in this case, according to this theta, is 8 over hypotenuse, which is 10. So this one is going to give us 8 over 10. If you reduce this, it's going to be 4 over 5. Okay, just like that. Then the area of triangle ABC. ABC, this is the area of triangle ABC, that's ABC. So as you can see, ABC is a non-right angle triangle. This one is a non-right angle triangle. Okay, so where we know that the area of a non-right angle triangle is given by half AB sine theta. So it's going to be half AB sine theta. That is what we know. Let us substitute our values and see, you guys, what you're going to have. Half of AB, which is half, times A and B. These are the sides that are creating our triangle, which is 10 here and 15. So it's half of 10. It's going to be half of 10 times 15 times sine theta. Now, the theta that we are talking about is supposed to be this one that I'm indicating here. But we know that on a straight line, this is an obtuse angle and this is an acute angle. And I told you guys that the sine of an obtuse angle is equal to the sine of the acute angle. So there we are given the acute angle and its value is there. We are given that the sine of this acute angle, this one, is given as 3 over 5 because theta is your acute angle. So it's the same value as the one for the what? For the obtuse angle. So this one is 3 over 5. So it also means this one is what? Is 3 over 5. So this is what you're going to multiply with, 3 over 5, just like that. So play around, 2 here, that's 5. 5 here, that's 1. 5, that's 3. Okay. So 3 times 3, that is 9. 9 times 5, which is 45 square centimeters. Remember, this is area measured in square units. That was it. So these questions, guys, they just want you to play around and understand. Do you understand this? Do you understand? That is what they're, that they're asking you. So you must be very, very clear about these typical questions. Okay. Anyways, we are given that from Bulawayo and Harare, that they are actually 400 kilometers apart by air. Okay, by air, it's 400 kilometers. A helicopter leaves Harare at 2:30 p.m., arrives in Harare at 4:10 p.m. Okay, on the same day. Calculate the average speed of the helicopter. Okay, so we need the time. Remember that speed is equivalent to distance over time. Here we are given the distance actually. It's 400 kilometers, so the distance by air is 400 kilometers. And we need the time. So we have to calculate from what? From 2:30 p.m. to 4:10 p.m. So I'm just going to use 24-hour notation. It's very easier for us to subtract using what? 24-hour notation. So what is 14:10 p.m.? This is 14, which is 16:10 hours. So this is 16:10 hours. And 2:30, 2 is 1400. So it's going to be 14:30. All right, so let's just subtract here. It's impossible for us to subtract 10 minus 30. It's impossible, so we have to borrow 1 hour here, which means we're going to be left with 15. And if we give that in minutes, this is going to be 60 plus 10, which is 70. Okay, 70 minus 30, that is 40 here. 15 minus 14, which is 1 hour. So you're going to have 1 hour, 40 minutes. So this is 1 hour, 40 minutes. And we know the time whenever you're calculating, this time is supposed to be in hours. So you have to convert 40 minutes to hours. That's 40 over 60. And if we reduce this by 2, that's 2 by 2, that's 3. So it's going to be 1 2/3 hours. Okay, so that's 1 2/3. So that's it, guys. Our answer can be calculated now because we've got the distance, 400 kilometers. All right, so this is 400 kilometers over the time. At least let us use this as improper fraction. You can multiply, that's 3 plus 2, which is 5. So it's going to be 5 over 3. All right, so you divide by 5 over 3 here. So this is distance in kilometers, and this is your time in hours. So it's going to be kilometers per hour. So if you divide this, it's just like you are multiplying 400 times. Remember, you are dividing. So the moment you introduce times, you invert this second fraction. So you're going to invert that, which is going to be 3 over 5. So this is 5, 1, 5, 8, 0 here. So it's 8 times 3, which is 240. All right, so this is 240, if I'm not mistaken here, kilometers per hour. All right, so just cross-check your calculations, guys, your numbers, and see if they are giving us the exact thing. All right, so that is just speed, distance over time. But make, guys, you see how they answer, how they want you to answer this question. They want you to apply the exact thing. Are you working with the actual time that you're given? Time is most important. Your time is supposed to be in hours. Okay, so that was it. Let's see the B, the arrival time in Bulawayo in 24-hour notation on the return of the journey. If the helicopter leaves Harare at 10:36 p.m. and takes 1 hour 49. So what is going to be the arrival time in Bulawayo? Okay, so what time is it going to arrive in Bulawayo if it is a condition like it leaves Harare at 10:36 p.m. and took 1 hour 45? So it's just a matter of what? Adding 10:36 in 24-hour notation. 10 is what? 22. So this is 22 hours. So it's going to be 22 hours 46. And we add 1 hour 49 because it took 1 hour 49 this time. So this time it took 1 hour 49. So we add these two. Okay, so let's add and see what time it to arrive. That's 15 here. Carry 1, 8 plus 1, which is 9, 3, and that's 2. All right. So it arrived at 23.95. But guys, does this make sense? Okay, it doesn't make sense. So which means we have to get rid of that hour there, remove 1 hour here, which is remove 60 minutes. We are going to remain with 35 minutes here. Okay, so we have removed 1 hour, so which means we have to give that 1 hour here. So we have to give this one an hour, which is now at 24. Okay, so it's now at 24.35, of which you know 24.35 is same as what? 00:35. That is it in 24-hour notation. Take note, the time here is needed. We are not told the arrival time in the 24-hour clock. It's given in the 24-hour clock. So which means your answer is going to be 00:35. That is what you were needed here, 00:35. All right, there's no dot here when you are dealing with what? A 24-hour clock, you don't put that dot. You can write hours. Yes, it's fine. You can write hours, but don't write that dot thing. Okay, so that was it, guys. As you can see, guys, please study. We do not have time now. The time is already out of hand. We have to study as much as we can. Not to sleep if possible. Yeah, if possible. Let us do that. Okay, number 19. It is given, we are given vector P, vector Q, so these are vectors. Then the first question is to calculate the modulus of P. This is the magnitude or the modulus or the length of a vector. Okay, leaving your answer in said form. So I told you guys that the modulus is simply what? The square root of x squared plus y squared, provided this is your x and this is your y. Okay, so in this case, we are going to have the modulus of P, which is equal to the square root of x. This is our x, which is 6. So it's going to be 6 squared plus y. In this case, this is our y, which is -4 squared. So just like that, we can simplify 36 from 6 squared plus 4 squared, which is 16. And if I add these two, we are going to obtain 52. Yeah, that's it. So you can even leave your answer like that in units, or you can simplify further since we know that in 52, we have got these two numbers that we can multiply. It's 4 times 13, if I'm not mistaken. All right. Need to be a little bit slow here. So it's 4 times 13 here, which gives us 32. That's the highest perfect square that we can have. So square root of 4 is 2. Square root of 13, we do not know this one. So it can be simplified to give us 2 square root of 13 in simplest form. Or you can use that idea of using, guys, work on your sets. I told you how to simplify expresses or product of its prime factor. Okay, let us just do it. 52 here, the smallest number is 2. 2 into 52, that's 2 into 5, which is 2, remainder 1. Into 6, into 12, that is 6. 2 into 26, that's 1. Into 6, that's 3. So 13 here. So these two numbers have got a pair. And I told you that the number that has got a pair, you write it outside of the square root. Then the one with a pair, you write it inside of the square root, just like that. Okay, so that's it for this particular question. Then you are given B. If P is parallel, take note here, if P is parallel to Q, calculate the value of Y. Okay, this is what I want you to know. Whenever you're given parallel vectors, it means they have a relationship between these two. What does it mean? The relationship can be Kp, which is a constant, is equal to Q. If P and Q are parallel, or P is equal to K, Q, where K is a scalar. Okay, if what? If P and Q are parallel vectors. So it means we have to multiply one vector by a constant to obtain another vector if these two are parallel vectors. All right. So what does it mean? I'm just going to pick, I don't know which one you're going to choose in this case. In this case, I'm going to choose the first one. K times vector P must give us vector Q. Okay, so what does it mean? I want us to take our vector K. Okay, I'm just going to remove this part again, guys. I hope we have, okay, in fact, we've done this part. So I'm just going to remove this part again so that at least it can help us. All right, so this is what you're going to have in this case. We are saying, using the first idea that I wrote there, I started with Kp. So K vector P must be equal to vector Q if they are parallel, or you can use the other one that I indicated. So just choose which one is the best for you. Okay, where K is a scalar. Okay, so what does this mean? It means K times P. This is your vector P here, which is 6 minus 4. You equate that one to vector Q. This is your vector Q, which is minus 15y, like this. Okay. So what have you done? You have formulated an equation. Since you want to calculate the value of y here, you are going to use this first part here. Okay. Remember, the scalar multiplies everything inside here. That's what a scalar does. Okay. So let's multiply by a scalar first. So it's k times 6, which is 6k. K times minus 4, which is minus 4k. Okay. And this is going to give us minus 15y, like this. Okay. So it means these two are equal. So what we can do is to find the value of k. That's what we can do from these two. We can use them to calculate the value of k from these two corresponding elements here, because we have got everything that is complete here. So I can use this to find the value of k. So it means 6k is going to be equal to negative 15. Okay, divide by 6, divide by 6. So k is going to be by 3, that is negative 5, by 3, that is 2. So it's going to give us negative 5 over 3. So that's what you're going to have in this case. All right. So if our k in this case is negative 5 over 2, so yeah, that's negative 5 over 2. Then what about the value of y? We now have to return here corresponding values here. We are saying these two, they are equal. So we are going to write minus 4k is equal to y. So I have the value of k, so I'm just going to multiply minus 4 times k. We said our k here is negative 5 over 2. So you multiply by negative 5 over 2, you obtain the value of y, just like that. So 2 into this one, it's negative 2. Negative 2 times negative 5, which is positive 10, which is equal to y. So in this case, y is going to give us positive 10. So that's how you work out these parallel vectors. Okay, so I want you to prove using this concept. Is remember we said we can use this part or we can use this one, P is equal to K vector Q. So I want you to work it from this side and see if you're going to obtain the same answer. The value of K cannot be the same, but the value of Y is going to be the same. Yes, the value of Y here is going to remain as 10. The value of K is not the same, but the value of Y is going to be the same. I mean, when you use this one here, you are going to obtain different value of K, but Y is going to give you 10. So I want you to try, guys, and see if you're obtaining the same answer. That's how you answer this type of equation whenever you are given parallel vectors, okay? That's the condition. And let's see, they were given a cubic function of Y is equal to x cubed minus 4x. So that's our cubic function. And the straight line of Y is equal to mx plus c. Okay, so the first question is to find the value of c. So the value of c, which is on this line, Y is equal to mx plus c. This is the line. So as you can see, the line crosses the y-axis at -2. Remember, c is the y-intercept. So that's it. So that is your y-intercept here, c. That's -2. B, the value of m. Remember that m is the gradient. So how do you find the gradient? You can even take 2 points on this line, okay? This is the line. You can just take 2 points and find the gradient. The first point here, that's 0 minus 2. Just take 2 points of your choice, okay? That's 0 minus 2 here. All right, so you're going to have 0 minus 2. Then this point here, is it clear? No. This point, is it clear? That's 1, 3. It's going to be 1, 3, if I'm not mistaken. That's 1, 3. Okay, that point is 1 minus 3. Okay, I think it's 1 minus 3. I think it's there. Minus 3 direct. Or you just, okay. Or even you can use this one here. Yes, this one is direct here. Minus 2, 0 there. Okay, it's another point. Minus 2, 0 like that. Okay, so like I said, this one I'm not certain. Is it directly at 1, 2, 3, 4, 5? 1, 2, 3, 4, 5. Yeah, that's it. Yeah, that's -3. So you can choose any 2 points of your choice. Then you calculate your gradient. Remember, your gradient m is equal to y2 minus y1 over x2 minus x1. Someone can use y1 minus y2 over x1 minus x2. Provided these are the same here, these are the same, okay? Or, but as for me, I'm just going to use it from the graph. Increase in y, I'm going to use this triangle here. Increase in y over increase in x. So I'm just going to utilize this triangle, this one. Okay, so this is my increase in y from -2 up to 0 here. So it's going to be +2. So m, that's increase in y, gradient over increase in x. So x here, from this point going this direction there to this point, I'm going to the negative, which is -2. So it's going to be -2. Which is -1. Okay, so that's my gradient. So like I said, guys, use the best method for you. You can use points. I gave you the points to use and the formula to use for gradient. So please do that and see if you're going to obtain the same answer. You must obtain the exact answer like this one, which is -1. So choose any points of your choice from there. That is m, which is the gradient, okay? Then on C, the gradient of y is equal to x cubed minus 4x at x is equal to 1. Okay, let's cross-check where x is equal to 1. This is where we have got our x is equal to 1. Okay, guys, remember this. I want you to cross-check from your cubic function or from your quadratic function. How do you find gradient on a curve? You know that when you are given a curve like this, you mark straight to the graph like this at this point. This is where the point lies. And on that point, you draw a suitable tangent. This is what you do, okay? Isn't it? You draw your suitable tangent like this. On that tangent, you then find the gradient of what? Of this line. Not the gradient of the curve, but the gradient of the line. Now, if you are to cross-check this line here of y is equal to mx plus c, this line that you have here, this one, is already your tangent at this point where x is equal to what? Where x is equal to 1 at this point. It's already your tangent. And you calculated its gradient before, and you said your gradient here is -1. So does it going to change? No, it is not going to change because that is your tangent now. That straight line that you found its gradient to be -1 is the same line that you want to calculate is gradient. And you know that the gradient on a straight line is the same throughout. So which means that line is going to be a gradient of what? Of -1. Okay. Then let's see the range of values of x for which mx plus c is greater than. Okay, this is what I want you to note. When you are given graphs like this, when another line or another curve is greater than another, let's just take an example of this part here. I'm just going to put it this way. Let's just take something like this one. Okay, this line here, when you are saying it's greater, we are just representing a region where one graph is above of the line, like this one here, from this point here up to this point here. This graph here is above this line. But once you start from this point here, going this direction, the line now is above of the graph, which means the line is now greater than the graph. That is what it means. So to be above another graph, that is where you are having a greater value. The one graph has to be above the other one. So it means we need a condition where the straight line is above the cubic function, just like this, what I indicated here. So let's cross-check from here. Where do we have our graph, our straight line? So I want you to cross-check here from this point here, this point. The line, this is your line here. It's below the graph because the graph is above, as you can see. So here the graph is the one that is above. As you can see, all this region, going to this region, going to up to this point at -2. At this point -2, the graph and the line, they intersect, which means at that point they are equal. The moment we move from -2 going this direction, as you can see, the line now is above of the graph because the graph now, this is a cubic function, is now going down like this. So this is the region where your straight line is above the line. And which region are you talking about? From these values of x, from these values of x here, which range from what? From -2, -3, -4, and so on. We do not know even these values, where are they going to end? So what are these values compared to -2? Are they greater than or they are less than -2? We are comparing values such as -3, -4, -5, -6, -7. These values, they are less than -2. So that is where our line is above the graph. So it's on a position where x is less than -2, not equal to 2. When it is equal to 2 at this point, when it is equal to -2 at this point here, when it is equal to -2 here, they are equal at this point. As you can see, at -2, they will be equal. So as we need this point when it is at what? From -2 going that direction, at this point going from. So not exactly at -2, because at -2, they will be what? They will be equal. Okay, so that is it, guys, as you can see. So like I said, all this region that we saw, all this region, the straight line was below the graph. As you can see, it was below the cubic function. This was a cubic function. It was below the graph. So it means your straight line was less than. Okay, that is it. So guys, you just have to work along. Much questions. Okay, number 21, it is given that m is given by the matrix, find m squared in terms of x. So m squared simply means m times m. So you just have matrix m, which is 2x, x, x, and 2x. Never make a mistake to square this, but multiply it 2 times. That is what it means. All right. So you have to multiply your matrix 2 times, and we know your matrix multiplication row by column. So it's this row versus that column. So let us multiply and see what we're going to have. 2x and 2x, yeah, that's 4x squared plus x and x, which is x squared. All right, we are done with this row and the column. We move on to the same row, but another column now. Okay, so let's do the multiplication here. So it's 2x and x, which is 2x squared, x and 2x, which is 2x squared. We are done with this row and the column. We move on to this row and the first column that we had. So we are going to have x and x, 2x. That's 2x squared, 2x and x, which is 2x squared. We are done with this row and column. We move on to the last column here. So it's going to be x and x, which is x squared, 2x and 2x, which is 4x squared. All right, so let's add This is same as 1 here, so you're going to add 4 plus 1, and this is going to give us 5x squared, 2 plus 2, which is 4x squared, and we add 2 plus 2, which is 4x squared. This is same as 1 here, so it's 1 plus 4, which is 5, so it's going to give us 5x squared. All right, so that is what you're going to have in this case. So as you can see, guys, it was just a matter of applying your multiplication, then after that, collect like terms and so forth. Okay, the B part, you are now given, find the value of x given that this here indicates determinant of, if you are dealing with matrices, this is determinant, okay? So they have given us determinant of M to be 48, and we know that our determinant is AD minus BC, like this. So this is your A, D minus BC. So A and D, you multiply these two, that is a 2x by 2x, okay, minus BC, which is x times x. So it's x times x. We must obtain 48, like that. All right, so let's multiply, guys, and see what you're going to have. 2 times 2, that is 4x squared, minus x times x, which is x squared, is going to give us 48. All right. Now you have to subtract. Yes, that's 4 minus, this is same as 1. 4 minus 1, that is 3. So you've got 3x squared is equal to 48. All right. Then divide by 3, both sides. Divide by 3, divide by 3 here. So x squared is going to be 3 into 48, which is 16. All right. So how do you find x? Definitely introduce the square root, both sides. So our x is going to be plus or minus 4. Okay. So that is our x, positive or minus 4. That was it. So as you can see, you've got two values. The other one was going to be a 4. The other one was going to be a minus 4. That is what it means. So even your answer, guys, must even give you direction of what are you supposed to do on that answer that you're given. It's very, very important that you understand the concept there. All right, then I think that was it. Just like that, we are done. Number 22, we are given the variation. It is given that y varies inversely as x plus 2. So it's something like this, varies inversely, that is 1 over x plus 4. So this is x plus 4. Express y in terms of x and a constant k. So here we need it in terms of a constant k. So that is going to be y is equal to the constant k over x plus 4, just like that. So that's your first item. B, given also that x is equal to 6 when y is equal to 2, find the value of k. So this is now your B. You just have to substitute the value of y here, which is 2. So 2 is equal to k over the value of x. We are given that x is 6. So it's going to be 6 plus 4. And 6 plus 4, that's 10. So 2 is equal to k over 10. So this is k over 10. So you can cross multiply to find the value of k as usual. 1 times k, that is k is equal to 10 times 2, which is 20. So that was it, guys. The value of k in this case was going to give us a 20 there. All right. Okay, then let's see the other part of the question. Find the value of x if y is equal to 8, okay? So what are you going to do? Since we now have the value of k, we are going to substitute it here first. Y is equal to k first. That's the first thing where we said our k is 20. So it is going to be 20 over x plus 4. So you write this as usual. All you just need was to substitute the value of k first, which is x plus 4. Now we are asked to find the value of x, that is x here, if y is equal to 8, okay? So y is equal to 8. So in place of y here, we have to put 8 here. So that is what you're given. So, okay, let's just use it like that. 8 is equal to 20 over x plus 4. So what is the value of x? So as you can see, guys, we have to cross multiply. And cross multiply means this has to multiply everything. 8 has to multiply x. So it's 8 times x, which is 8x, or you can open brackets, plus 8 times 4, which is 32, is equal to 1 times 20. That's a 20 there. All right, so let's transpose. and see what you're going to have. 8x is going to be to this side, which means we have to subtract 20 minus 32. That's 32 minus 20, which is 12. And you take the sign of the bigger number, that's a minus. Okay, divide by 8 both sides, by 8 both sides, as you can see, to clear the x there. So you can clear this. So our x divided by 4, that's a negative 3 by 4 here, that's a 2. So our x is going to be minus 3 over 2 or minus 1.5. All right, so that was it for the value of x. You just have to make sure that you are applying your substitution properly, and by doing that, everything is clear, as you can see, guys. Okay, so that is what you are given. Let's see the other part. 23, at a certain party ratio, men as to women as to children, that is 5 as to 6, that is what we're given, the party that is men. If there are 80 children at the party, calculate the total number of people that are at the party there. So here we are given the ratio, so you have to add because you need the total. So if you add, that's 10, 6 plus 4, that's 10 plus 5, which is 15. So 15 is the one that represents the total number of people, which you do not know. But you are given that there are 80 children, and it's men as to women as to children. So that is men as to women as to children. All right, so the children here is got a ratio of 4. So 4, according to ratio, gives us 80. So what about 15? So it's here, I'm asking yourself here, so what is 15 going to give us? So it's more. So it's 15 over 4 multiplied by 80. So you just have to multiply these two. Okay, this is 20 here. And 20 times 15, which is going to give us 300, if I'm not mistaken. So there are 300, all of them. That was it. B, the area of a certain country is given as 8,6 times 10 to the power of 2 square kilometers to the power of 6 square kilometers. And the area of country's map, this one, take note, we are given the actual area and the one that is on the map. That is what we are given in this case. All right. So we are asked now to find this ratio in its simplest form. So remember, guys, I told you that there must be a great relationship between these two. And always when it is in the form of 1 as to n, the 1 here represents what is on the map, the n, what is on the actual ground. Okay, so let's start with what is on the map. Okay, I'm just going to remove this part again. Here, I'm just going to remove this part here. All right. So we are going to start with what is on the map. The country's map here, this is the map is given by. So this is the map 3,4 times 10 to the power of 5 square centimeters as to the actual now, which is the real area, which is 8,5 times 10 to the power of 6. This is a square kilometers. Okay, so the question is for us to find the scale, and these are square, which means here you are working with area factor. This is area, this one. These are square units, which means you've got area factor. You need to find the scale factor first. Okay, you need to find the scale factor. That is what they are asking here, 1 as to n. But before we do that, we must have the same units. Remember, guys, that you must have the same units. So how are we going to have the same units? That is the question that we have got here. How are we going to have the same units? Remember, guys, I told you that if you are dealing with square kilometers and square meters, it's actually converting these to square centimeters, because this is square kilometers. Okay, so you're going to have something like this, 3,4 times 10 to the power of 5. We are still on area, but these are square centimeters. Okay, as to 8,5 times 10 to the power of 6, which are square kilometers. So let us convert square kilometers to square meters. Okay, what do we have? We know that in a kilometer, we have got 100,000. This is actually 100,000 centimeters. Okay, this is 100,000 centimeters. So if we square this, we are going to have 100 to the exponent of 2, which is like 100,000 is actually times 10 to the power of 5. Okay, like this, times 10 to the power of 5 times 10 to the power of 5 again, that's to square. We have to multiply like 5 plus 5, which is 10. So it's actually it was going to give us 100,000. Then we square that 100,000. So squaring 100,000 is simply multiplying it twice. So it is going to give us 10 to the power of 5 plus 5, which is 10. 5 plus 5, that's 10. All right, so this is going to be 10. So if we multiply this here by 10 to the power of 10, it means now we have got same units. We are now having square centimeters, square centimeters. So the square centimeter and square centimeter can cancel. And here I'm going to reduce to the power of 5 here into this here. I'm going to be left with how many? There were actually 5, so I'm going to be left with 5. So I'm going to be left with 10 to the power of 5 here. Okay, so that's it. Here I'm going to be left with 3, 4. Okay, let's write stage by stage. Okay, 3, 4 S2, 8, 5 times 10 to the power of 5. Here we're multiplying the base, which are the same. So you add the powers, that's 6 plus 5, which is 11. All right. Remember how we remove the exponents, guys. Remember how do we remove these exponents here? So what are you going to do? We can reduce here by 3, 4, since we want it in the form of our S1. So you can reduce this by 3, 4 by 3, 4 here. So this can cancel, which means we are going to be left with 1 S2. And if you multiply properly, if we divide properly, 8, 5 divide by 3, 4, this is actually like how many times? 5 times, or 2, 5, yeah, something like this. It's going to be 2, 5. Okay, so this is going to give us 2, 5 times 10 to the power of 11. So remember, guys, we are still under area factor. And what we need now is to find the scale factor, which is the ratio of 1:n. So this is for area, this one. But here they need the scale, which was used for drawing, not for area. So which means for drawing, we have to find the square root now. All right, that will be your scale factor. So square root both sides, square root both sides. Remember, from area factor to scale factor, you square root. But from scale factor to area factor, you square. So it's the opposite now. You are from area factor, you want to go to the scale factor, you put the square root both sides. So square root of 1 is 1S2. Can we find the square root of 2,5? No, it's impossible. So what are you going to do? We just have to convert this in a number that you can find its square root, which is, let's simplify aside, 2,5 times 10 to the power of 11 is same as, if we move 1 comma here, it's going to be 25 times 10 to the power of minus 1. It's just going to be to the power of 1. Okay, so minus 1, because here we are like going this side, like we are opposing what we are supposed to happen. Okay, times 10 to the power of 11. So if we add minus 1 plus 11, that's 10. So it's going to be 25 times 10 to the power of 10. Okay, so this is going to be square root of 25 times 10 to the power of 10, which is 1S2. Square root of 25, that is 5 times 10 to the power of square root of 10 to the power of 10, that is 10 to the power of 5. You just have to divide. So this was your scale, guys. 1S2, 5 times 10 to the power of 10 like this, or you can write it as 1S2 500,000 like this. So this was the scale which was used. So guys, as you can see, yeah, it had a lot of things that we had to consider. There are a lot of things that we had to consider, and yeah, it's actually fine to have such typical questions in exam. In exam, is supposed to have one question which stretches you further. Okay, not all the questions to be like fine like that. Okay, at least one question that stretches you further. Yeah, like this one, it will stretch you further, I can see. Okay, anyways, let's see. The construction part now is the difficult part. I do not have the exact things, guys, but here we are given to construct the locus of points equidistant from A and C. Guys, as you know that A and is equidistant from A and C, we have to find half of the line from this point A to C. So, you know, to find that, you open more than half, you mark an arc there, another arc there, You do the same at C, then you join. So here I'm just showing you like what you're supposed to have done. Here I'm not having the actual instruments, but you're supposed to have something of that nature that is perpendicular at what? At 90 degrees, something of that nature. And the locus of points equidistant from AT and BT. This is your AT and BT here. AT, BT. So they repeat at angle T. So you bisect this angle at T, that is the locus. You bisect this one. And I told you guys how to bisect angles. You just mark arcs on those and that angle that you want to construct, and you join to the what? To the angle that you are bisecting through this point to point T. It must pass through the point T. I'm just like a sketch, guys, as you can see. Then write down the radius of the circle. The radius of the circle, you are going to measure it. These 2 points, they are going to meet at one point like this, okay? Then you just measure from that point to any point on the circumference, any point. It can be here, it can be here, as long it is from this center, that becomes your radius. Okay, so that one, can you do it? Can you do it? Can you do it? And finish and see you're going to obtain what you're going to obtain. All right, so this is 3 here. All right, so there we are given a diagram where we are given the parallel lines, the points and so forth. And the question is to describe fully the single transformation which maps ABC onto EDC. Okay, this is EDC. So this is your ABC, which is this bigger triangle, onto this. Okay, I told you guys on this type of equation, it's always an enlargement. As long there's a bigger shape and a smaller shape, that one is an enlargement. But if these two are equal, that one, it is going to be a rotation. So take note, this type of equation can be under enlargement or under rotation. If it is like this, it is a rotation when these two are congruent. So it can be asked this type of equation when they are congruent, but when they are similar like this one, these are similar figures. So that one is enlargement. All right. So this is what you're going to have here. So definitely here we are going to have, it is an enlargement. An enlargement here. So it is enlargement. Then we know that for enlargement, we need the center of enlargement. So the center is about where these two meet. They meet at this point C. So center C. So it's going to be center C. And we need the scale factor. Remember, for enlargement, we need the scale factor. If you still remember, guys, on enlargement, I told you that enlargement, you can actually use the image line over the object line. So the image line, remember we said A, which maps A, B, C onto this. So this is our image and this is our object. All right, so that is what we have. So this is our image here. So the image, you can use this advantage of this 3, that is the image line, 3 over the object, which is 9. So it's going to be 3 over 9. So that's 3 over 9. And as you can cross-check, I told you also in enlargement that if the two diagrams are separate like this, one on the other side, one on the other side, it means your scale factor is going to be a negative. Okay, so here we are going to have our scale factor being a negative. So it is going to be negative 1 over 3. That is your scale factor. Okay, why a negative? Why having a fraction? As you can see, the image here is smaller than the object. As you can see, the image is smaller than the object. That's why you're obtaining a fractional scale factor. If A, B, C, D, this one, if A, B, C, this one, if this was our image, let's say this is our image and this is our object, the scale factor was going to be a whole number because it was going to be image 9 over object, which is 3. So it was going to be 9 over 3, and it was going to give us a negative 3. But now they say this is your image and this is your object. So take note, the image, when the image is smaller than the object, the scale factor is a fraction. Okay, so this one, please take note about it. All right, so I think that was it. A, B, C is mapped onto triangle A1, B1, C1 by a transformation represented by this matrix. Calculate the coordinates of P1, which is the image. Okay, guys, whenever you're given a transformation with matrix like this, matrix times object must give us the image, full stop, just like that. So you have got the matrix for enlargement, which is 2, 0, 0, 3, multiplied by the object. What are you mapping? You are given to find the coordinates of B. So we are going to multiply B and find the image of B. So where is your B? Let's cross-check on our diagram. Our B is there. We are given the coordinate here at B. B is what? Is 12, 9. So we are going to multiply that. We are done. The moment we multiply this, we now have our image, just like that. So row by column, row by column. So that's row by column 2 times 12, which is 24, plus 0 times 9, that's a 0 here. Row by column 0 times 12, that's 0 plus 3 times 9, which is 27. All right, then we add this, is going to give us 24, 27. So as a point B, the image of B is going to be 24, 27. That's it. So sometimes they can even ask you to describe the transformation using matrices. So guys, I told you, you must know how to describe all these matrices, transformation using matrices. You must know how to describe such typical questions. Okay, but that was it. That was it, guys. As you can see, matrix times object, you get your image. 26, yeah, that's 26 there. We are given the logarithm of 2, the logarithm of 3, calculate log 6. So this one, guys, it was a pretty direct. Log 2 times 3, isn't it? That is direct, guys, as you can see. So it's log 2 plus log 3. You now ask yourself, what happened for you to multiply these? You're adding the logarithms log 2 to log 3, and log 3 is there, which is 0, 0,3010 plus log 3 is there, which is 0,4771. So if you add this properly, you're going to obtain 0,7781. All right, so that was it. What about log 1,5? That is on B. So log 1,5, just write it as a fraction. 1,5 is same as 15 over 10. So you can reduce by 5, that is 3, by 5, that is 2. So this is same as log 3 over 2. So as you can see, we are dividing the logarithms, which means we are dividing the numbers, sorry, not the log, we are dividing the numbers. It means we were subtracting the logarithms, that is log of 2 minus log of 3. And log of 3 is there, that's 0,4771 minus the log of 2, we are given log of 2, which is 0,3010, like that. Okay, so I want you to subtract these numbers, guys, properly. You're going to obtain something like 0,1761. All right, so make sure you do your subtraction properly, guys. All right, then the C, which is log square root of 2. So let's cross-check from our indices there. Where did the square root came from? It came from 2 to the power of a half. So this 2 to the power square root is same as 2 to the power of a half, this one from our indices. So it was 2 to the exponent of a half, where we know that from our law P log M. Remember your P log M, guys, which gave us log M to the exponent of P. So there we just have to drop the the power here. It's going to be half. So it was half log 2, just like that. So let's substitute whatever that we are given here, which is going to be half times log 2 here. All right. So it's going to be half times log 2, and we have got the value of log 2 from this information, which is 0,3010. Okay, so this is 0,3010, like that. Okay, so that's it. You have to reduce, guys, until you get the answer. 2 into 0, that's 0, 2 into 3, that is 1, remainder 1, into 10, that is 5, 2 into 1, you do it stage by stage. 2 into 1 first, that's a 0. You put a 1 here, so it's 2 into 10, which is 5. Guys, take note how you divide there. All right, so that's it from this part that we are given. As you can see, that was the last part of the paper that we are having. So in this case, let us try to revise as much as we can, guys, and don't forget to share our platform, guys, our videos to your friends and colleagues, so that they also can have a benefit from this information that we are having from Maison African Motives, as we are trying by all means to cater all the papers if possible, all the revisions that we can as we are preparing ourselves for the exams which are ahead of time. So please, we do not have time. Like I was saying, guys, time is not there. So please try to revise as much as you can. If it means not to sleep, then let it be like that. We do not have time. So that's it, guys, from Mason African Motives. Till we meet again.